Okay, welcome back to video 3. We're doing the second section, 2.7 for Friday, January 24th, and it's the rational root theorem, and it's only one idea, so this will be the last video for today, and then you can start on your homework assignment. Alright, so let's get started. So on your notes, go to 2.7, the rational zero theorem. And some things we want to try to remember, that a polynomial function of n degree, n degree means like x to the fifth, n equals 5 then, like so the fifth degree, can have at most n real zeros. So if it's a fifth degree function, it can have at the most, doesn't mean it does, 5 real zeros. Real can be rational or irrational. And so rational would be like 5/3 or 3/5, plus or minus 3/5. And irrational would be like plus or minus square root of 2, right? Or 3 plus or minus the square root of 5. Those are irrational. So when we're talking about rational zeros, we can say that rational zeros are those that can be written in the form a over b as a fraction. So like 3/5, or even 1 is a rational zero because you can write it as 1 over 1. So this is a theorem about the rational zeros that a polynomial might have. All right, so here's what the rational zero theorem says. It can be used to determine all possible rational zeros of a polynomial function. So using this theorem can help you get all possibilities. Not that they are, but that they're the possibilities. And so say you have just a normal polynomial. So I'm going to write one like 5x to the third plus 3x squared plus 2x plus 1. And it has integer coefficients. And every rational zero of the function has the following, then every rational zero has the following form. Okay, P is the factors of the constant term. In our example, it would be the factors of 1. And Q are the factors of the leading coefficient. So P is this guy and Q is this guy. All right, and so when we say P over Q, we're talking about all the possible factors of P and all the factors of Q. And then you could put P over Q to make a list. So the possible factors of 1 is just 1. Okay? The possible factors of Q are 1 and 5. So for this polynomial, the possible rational factors could be the possible rational zeros could be 1 over 1. So we're doing all P over Q's. So first you take this one and put it over that. So that'd be 1 over 1. And then 1 over 5. And so it only has 2. And, 4, because you always say plus or minus, because it could be either one, plus or minus. So P over Q. So when you were trying synthetic division and you're looking for a zero, if you couldn't factor it or do anything else, you could always try, hey, let me just use P over Q. And that means when you do synthetic division, it's going to be trial or error. So I think I might be getting a little ahead of myself. Let's just see if we can't figure out some of the possible rational zeros for some polynomials, okay? You'll see what I mean. So I'm just going to start with this first section. P, in this case, I'm just identifying it ahead of time, is 2, and Q from here, and Q is 1, because the coefficient of x cubed is 1. The leading coefficient is 1. So possible P's, the factors of P are 1 and 2 is only, and the factors of Q are just 1. So all possibilities of P over Q are 1 over 1, so plus or minus, I'll just write 1 for 1 over 1, and plus or minus 2 over 1. So I'll just write plus or minus 2. So that would be the possible factors for, I say factors, the possible rational zeros. So, okay, let's look at number 2. We have an 18, so that's P, and that has quite a few factors. 1 times 18, and then 2 times 9, and then 3 times 6, and then so then you would do the backwards 6 times 3, and 9 times 2, and 18 times 1. Okay, so those are all the possible factors of P, and then Q is 1. So it's just going to be all of these over 1. So the possibilities are plus or minus 1 over 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. Okay, I hope you're starting to catch on. In this one, number 3, P is 1. So the factors of 1 are 1 and 1. And Q is 4. So that would be 1, 2, and 4. Those are the factors of Q. So if I do every combination of P over Q, it's going to be 1 over 1. So that's plus or minus 1. 1 over 2, so that's plus or minus 1/2, and 1 over 4, which is plus or minus 1/4. Okay, let's do, this one's going to have more, so I'm going to try to write smaller. Let me make this guy smaller. Okay, and erase that stray mark. Okay, so here we go. This is P, 16. So the factors of 16 are 1, 2, 4, 8, and 16. And the factors of Q, this is 3, Q is 3, are 1 and 3. Now I have to make every combination of P over Q. So I'm going to just start with each of these and put them over these. So first I have 1 over 1, so that's plus or minus 1. And then 1 over 3, so that's plus or minus 1/3. And then I have 2 over 1, so that's plus or minus 2. And 2 over 3, plus or minus 2/3. And then plus or minus 4 over 1, so that's 4. And plus or minus 4/3. I have plus or minus 8 over 1, and plus or minus 8/3. Plus or minus 16 over 1, and plus or minus 16/3. So all of those, it's in a set. It's a set of all possible. This polynomial right here could have these possible rational zeros. Now look, it couldn't have any other ones. Like that's the whole point of writing these out. If we had to test synthetic division and we're looking hard for a factor to work, to go something that goes in evenly, we could try any of these, but we wouldn't try like 5 because 5's not in this list. So it reduces the trial and error down quite a bit. Okay, so let's go to number 5. I'll just do one more. So this is P is 12, so the factors of that would be 1, 2, 3, 4, 6, and 12. And Q is 6, so that'd be 1, 2, 3, and 6. And now every combination of P over Q, okay, so there's going to be a lot of fractions here. And if you have doubles, you don't write them down. So plus or minus 1, plus or minus 1/2, plus or minus 1/3, and plus or minus 1/6. So that takes care of 1 and all the Q's. So now go to 2. So it's plus or minus 2. Now plus or minus 2 over 2 is just 1, so I don't repeat that. Plus or minus 2/3 though is a new one. plus or minus 2 6 is 1/3. That's already here. So I'm done with 2. Now I have 3 plus or minus 3. That's 3 over 1. Plus or minus 3/2. That's new. Plus or minus 3/3, which is 1. And plus or minus 3 over 6, which is a half. So those aren't new. Keep going. 4, so plus or minus 4. 4/2 is 2, which is already here. 4/3 is 1 1/3. So do I have 1 1/3? That would be, no, I don't have 4/3. So plus or minus 4/3. And then 4 6 would be 2/3, and I do have that. So that's 4. I'm almost there. Plus or minus 6 over 1. 6 over 2 is 3. 6 over 3 is 2. And 6 over 6 is 1. So we're done with 6. And then plus or minus 12. And then 12 over 2 is 6. 12 over 3 is 4. And 12 over 6 is 2. So those are all the possible rational zeros this polynomial could have. Okay, so that's the first kind of idea. Learning how to get P over Q. And I'll say that when we're trying to figure out zeros, I'll say, well, can you factor it? No. Can you, is it a quadratic? Is there, can you use the quadratic formula? Can you complete the square? Can you, and then if we're all out of options, we'll say, well, use P over Q in synthetic division. So I'll show you what that means in the next video.